Finding the restaurant with the smallest combined index looks like a double loop, but a hash map turns it into linear time. You are given two arrays of strings, each representing a person's favorite restaurants in order of preference. The task is to return all restaurants that appear in both lists and have the minimum possible sum of their indices. If several restaurants share the same minimum sum, include all of them. For example, List 1 contains Shogun, Tapioca Express, Burger King, KFC. List 2 contains Piety, The Grill, Hungry Hippopotamus, Shogun. The only common restaurant is Shogun, at index 0 in the first list and index 3 in the second, giving a sum of 3, so the answer is just Shogun. The straightforward way is to compare every restaurant in the first list with every restaurant in the second list. That double loop runs in x.y time where n and m are the lengths of the two lists, while using only constant extra space. When the lists grow to thousands of entries, the quadratic work becomes a bottleneck, so we need a faster method. The key insight is to store the index of each restaurant from the first list in a dictionary, then scan the second list once. First, we create an empty dictionary. We walk through the first list, inserting each restaurant name as a key with its index as the value. Next, we initialize a variable for the smallest index sum found so far, set to a very large number, and an empty collection for the results. Then we iterate over the second list. For each restaurant, we check if it exists in the dictionary. If it does, we retrieve the stored index from the first list, add the current index from the second list, and compare the sum to our current minimum. If the new sum is smaller, we update the minimum and replace the result collection with just this restaurant. If the sum equals the minimum, we simply add the restaurant to the results. After the loop finishes, the result collection holds all restaurants with the minimal index sum. Let's trace the example. We start by building the dictionary from list 1. Shogun maps to 0, Tapioca Express to 1, Burger King to 2, KFC to 3. Minimum sum is set to infinity, results empty. Now we scan list 2. First entry Piety is not in the dictionary, skip. The Grill not present, skip. Hungry Hippopotamus not present, skip. Shogun is found with stored index 0. Current index in list 2 is 3, sum is 3. Since 3 is less than infinity, we update minimum sum to 3 and set results to contain only Shogun. End of loop. The final result list is Shogun. You'll recognize this pattern when you need to match elements across two collections and care about their positions. Anytime you see common items with minimum index sum. Time complexity is O, n plus m, because we traverse each list once. Space complexity is big O of n for the dictionary storing the first list's entries. Try the next problem, same pattern. If you found this helpful, hit subscribe for more concise algorithm walkthroughs.